Hello everyone, this is Mrs. Lindsay Pereira. Today we're going to start talking about angles. And we're going to start off by defining what is an angle. An angle is formed by two rays, so that's important to highlight there, two rays, which begin at the same point. That same point is what we call the vertex. Okay. Sides of the angles, again, are two rays that form the angle. And again, these are the sides of the angle. So in our example down here, that would be ray PS, or in other words, a side, and a ray PQ. So again, the side of the angle. And the common point for both of them in this case is P, right down here. So that is your vertex of this angle. Okay? All right, so let's talk about how can we actually name some angles here. Okay, three different ways. Number one, a capital letter at its vertex. So for our example here, that would be angle P. A number that's written within the angle, angle 1. Or by three capital letters. The middle letter is always the vertex. Again, a very important part there that I'm going to highlight. The middle letter is the vertex. The other 2 points are on the sides of the rays. So you could have named it either angle SP, so again, P is in the middle, Q, or QPS. So again, the vertex has to be the middle letter, okay? When in doubt, you can always name an angle by the three capital letters. You cannot always do number 1 and number 2, but number 3 will always work, again, using 3 letters. So let's practice a little bit. So name these angles in different ways, okay? So here's our first one. So we have no number that we can use, but we do have one capital letter, so we could do that as angle J. And then we can use our 3 letters. So again, J is the important part. It's the vertex. It must be the middle one. So I could go here and I could go I, J, K for my first one. So angle I, J, K. And notice that I'm putting a little angle symbol right in front of each of these. Kind of looks like a less than symbol, but it's not quite. But again, you put a little angle there. Okay. And then we can go in the other direction. So you can go angle K, J, L. So again, the important part that the vertex is in the middle, okay? Now we have a lot of angles, okay? So my first question here is, how many angles are there actually? And I'm hoping that you say 3. We have this angle, I'm going to put a number here. We have this angle over to the left, so angle ABD. We have the angle over on the right, angle CBD. But then we also have the larger angle, which is the straight angle, angle ABC. And we're going to talk more about different types of angles as we move along through here. So I put these numbers here. So technically, I'm okay with putting numbers in there and using that to mark those angles, but let's kind of step backwards here just a little bit. And let's just start with this one that I marked angle 1. Okay, so I can mark that as angle 1, or I could have done angle ABD, or angle DBA. So again, B is the vertex here. So I could have named it in either direction. B just has to be in the middle. But I cannot do this, angle B. Very, very important. This would be incorrect for this diagram. And the reason being is because there's 1 angle, 2 angles, 3 angles that have vertex B. So a lot of people say, well, it's just a larger angle. You can't assume that. You don't know which angle you're referring to because there are, again, 3 angles, the left, the right, and the straight angle that have the same vertex. Okay? So it doesn't ask us to name it in every single way, so I did not have to do all three of these. You can simply just pick one. Okay, now I put that angle 1 on there. I'm going to erase these. So this one names this angle over here, but if I want to name the angle on the right, this angle here, again, there's a few different ways I can do it. I can do angle CBD. Again, the vertex has to be in the middle, or I can reverse that order. Okay, again, I cannot do angle B. Okay, so I could do angle DBC or angle CBD. You do not have to put both. And then last but not least, I have my straight angle here, which again has vertex B, so that would be angle ABC, or again I can reverse CBA as long as B is in the middle. Okay, and I do have these solutions written down here as well, but again, you didn't have to put both. Pick one of each of those. That is the actual order there. Okay. So now let's talk about different types of angles. Okay. Yes, we have acute angles, obtuse angles, right angles, and even straight angles, as I mentioned there before. So this gives us a little diagram and tells us a little bit of information about them. Acute angles measure greater than 0 and less than 90. Right angles measure exactly 90 degrees, and we use this little box to identify that it's a right angle. So if that is written on a diagram, we know it's a right angle. If it is not there, so if you literally see an angle that looks like this, even though it looks like it's 90 degrees, we cannot assume it because it could be 89 degrees. If it's 89 degrees, then it's acute. It could be 91 degrees. If it's 91 degrees, then it's obtuse. So you must see this little box here. Super important. That box has to be there, or it has to be told to you in the directions or something like that to know it's 90 degrees. Okay. Obtuse is greater than 90, but less than 180. And then this was from our previous diagram. It's just a straight line, or in other words, a straight angle, and that measures exactly 180 degrees. Okay. So let's take a look at some of our different types of angles here. Okay, at this point in time, I'd actually like you to pause the video, and I want you to graph these points, plot these points on a coordinate plane, and then once you do that, please push play on the video and we'll go from there. So pause the video and plot those points. Okay, so here are all of my points, and let's take a look at these angles. So starting with the first one here, so I have angle DBE, and hopefully you look at that angle and you see that that is acute because it's going to be less than 90 degrees. 90 degrees is a good kind of reference because 90 degrees is going to be, since we're doing this on the coordinate plane, we can assume this is a right angle if we see a vertical and horizontal line forming that right angle right in there. So that is going to give us an acute angle. Do not worry about the degrees right now. That's too specific. We could actually get out a protractor and measure, but we won't do that. Okay. Then if I take a look here, and I'm going to get a lot of angles drawn on here, so I apologize for that. But if we take a look at angle EBC, so I'll highlight that here. So that's going to be EBC. I'll do this one in, oops, I meant to do it in green. So we'll do EBC. That one again, we're kind of looking here, that is going to give us that right angle. Okay. Third one, I'll do that in blue, ABC. And hopefully you see right there, I was able to draw just a single straight line. So again, that's going to be your 180 degrees there. And again, I'm not really worried about the degree measure right now, but that would be the 180. And then last but not least, ABD. So that's going to be past this. So you can see this would be your 90 degrees. We went past that. Again, don't worry about the degree measure. It's just simply obtuse. Okay, so just looking at those measures for right now in terms of identifying acute obtuse, right, and straight angles. We'll usually do more specific types of problems, but just identifying those right now, okay? So congruent angles. We have congruent angles just like we have congruent segments. So same shape, same measure. How do we mark those angles? Well, again, we use little arcs, and the arcs need to match. So this means these two angles, angle JKL, is congruent to angle MNO. And again, please notice I put the vertex in the middle. So that means they are the same measure. So if the markings match, the angles match. So this would be angle DEF. That is congruent to angle IHG. And again, notice that the vertex is in the middle. Okay? And we also have bisectors, just like we would do with segments. Okay? This time it cannot be a point. On a segment you can have a point, or you could have either a line or a ray bisect a segment. This one must be a ray. Okay? It could technically be a line or a segment as well, but usually it is a ray. So it would divide it into two adjacent, and that means next to, angles. So if I know that QR bisects angle PQS, okay, so what it's saying right up here, I know angle PQR is congruent to angle RQS. And it's absolutely okay, if you know something to be congruent, it's absolutely okay to put those markings on the diagram, so that helps you remember that they are congruent to each other. Okay? So let's do a few more examples here. Okay, so this is actually the angle addition postulate. Again, I really don't necessarily use that terminology, but occasionally you'll see that in the book. But we actually need to draw this diagram. So when I draw this diagram, this is the statement I'm really looking at. So I have an angle formed by two rays. H, again, the middle one has to be the vertex, so HJL. So I'll put a point here, H, J, and then L. We know ray, JK, so I'll put a K here, bisects it. So that means it divides it into two congruent segments. Notice how I'm labeling my entire diagram. Very, very important. Write your diagram down and label it with congruent statements or any other information they give you. So if we keep reading, it says, given that angle HJL is 42 degrees, so here's HJL. So this whole angle, that's sometimes hard to mark. So what I like to do is kind of just put a line out here, meaning the whole angle HJL is 42 degrees. So then it says, what are the measures of the angles HJK and KJL? Well, hopefully you remember here that it says that these are bisecting, so these would be equal. So all I need to do for both of these angles is take 42 and divide it by 2. So that would give us 21 degrees. And again, they're congruent because it's bisecting, so they both would be that. Okay. All right, let's try another one. The cellular phone tower bisects the angle formed by the two wires. So super important. Again, I'm going to highlight here. Notice how I keep highlighting. I keep reading things over and over again. So a cell phone tower bisects the angle formed by the two wires. So the tower bisects it. So here's my two wires. So I know this tower right here bisects and divides it into two congruent angles. So now it says find the measure of the angle formed by the two wires. So again, formed by the two wires. Wire 1, wire 2. That's the angle I'm looking for right there. Well, again, because I could put these congruent statements on there because I knew it was bisecting, if this angle is 47, So is this one. So to find this angle here, the larger angle, I need to add these two inside angles, which total up the whole angle. So if I take 47 plus 47, I get that to be 94. Okay. And our last example. So we have a diagram here. Actually, let me make this a little bit smaller so I can fit everything on here. Might be too small. I'll make it a little bit bigger. Okay, so in the diagram, we have MO, again highlighting here, MO bisects angle, sorry, that was supposed to be a highlighter, not a pen, bisects angle LMO. So I believe I said O, it's supposed to be LMN. It's bisected. So again, I can come over here and mark that they are congruent, the two inside angles. The measures of the two congruent angles, so what I just marked, are 3x minus 10. So I'm going to just mark this one as 3x minus, I'm sorry, I said 10, and it should be 20. Kind of looking ahead here. And the other one is x plus 10. So again, I'm labeling my diagram. Super important, okay? It's asking us to find two things. Solve for x, then the measure of all the angles. Well, look, we need to pull the equation off the diagram. Again, since I see that these are congruent to each other, that means these two expressions are the same. So in other words, they equal each other. Now I have a nice little equation that I can solve here. I can subtract x. I can add the 20 over and then divide everything by 2. So I get x to be 15. So that's our first step there. Okay? So we solved for x. Now we want to find the measure of all three angles. Well, let's talk about this one. If we know x is 15 and I plug that in, 15 plus 10, so this angle is going to be 25 degrees. You can plug in 15 here as well, but again, we know they're congruent. So we automatically know this has to be 25 degrees. Okay, so the two smaller angles are 25. Well, they form the larger angle LMN, so I just simply need to add those together and I get that to be 50. Okay, so we get x is 15. Plugging that into both of our expressions, we get the two smaller angles to be 25, and therefore the larger one is 50. Okay? All right, so this concludes our notes on the first day of section 1.5.